Hi everyone, myself Satyan Jaiswal and welcome back to my channel Coding Card. So in our previous session, I explained you how to solve a grid problem where we started with a simple problem for counting the island in which we traverse in up, down, left and right direction, and later on I explained you one problem where we traversed in all the 8 direction. So if you haven't watched that video, I will suggest you to go and first watch those two videos so that this problem will be very easy for you. Although they have marked it as a difficult, but this is a very simple one. First go and solve those two problems. That will be my suggestion. Anyway, let me explain you this problem here. So you can go through this problem from your end, but I will explain you here. So for example, this was our explanation for the counting the island problems where we were moving in all the 8 direction in our last problem. Now that problem was to count the total number of island. But this HackerRank problem is about the largest island. Just think of this is a grid. Just take these two examples. There they have taken 0 and 1 as a value in the grid. Here we have taken W and L for water and land. They have taken 0 and 1 as their input. So 0 is water and 1 is land in that HackerRank problem. Now the problem states that you will be given a grid and you have to traverse the grid in all the 8 directions. And what you have to do, you have to traverse the total grid which they will be providing you, and you have to find the largest island. So for example, let us take this one as an example. So here suppose this was the given grid. So one, we have this one island, there is this one we have this island, and one is this one. So here we have total 4 island, but the largest one is of size how much? 2. So we have to return these 2, means we have to return the size, means the largest size in this problem. For example, let's take this second example. Here we have one island, here we have one island, other one is this one in which we were traversing in diagonal direction as well. So this is one another island. So here total how many islands are here? 3. But the maximum size of the island is how much? 1, 2, 3, 4, 5. 5 means 5 cells are being connected. So we have to return 5 here. And here, third example, suppose this is the input grid. So you can see here, we got only a single island which was being discovered moving in all the 8 directions. So 1, 2, 3, 4, 5, 6, 7, 8 and 9. So here the count is how much? Maximum size is 9 and count is 1. We have one island and that is maximum of the total count 9. Now let us take their sample input. So for example, if we take this one, this one, so their input is in form of 0 and 1. So 1 is, so here the input format is in the form of 1 and 0. So 1 is land and 0 is water. So previously in our two problem we solved by taking the input format as W and L. Now see here, for this given problem, the total number of island is how much? This is one island, because for this one here you have water, water, water. For this one we can move down, for this one we can go diagonally up, diagonally left and right. So here we have total 2 island, right? And the maximum is how much? 1, 2, 3, 4, 5. 5 cells are being connected. So we have to return the only the size. and that will be also the maximum one. So here the output will be 5. See here, they have returned output as a 5. So this is the problem. We have to traverse in the grid, count the total number of island, and from that island, which island is having the maximum total number of cell connected with each other while traversing in all the 8 direction, right? So the problem is very simple. If you have solved these two problems, so it's simply like traversing in the grid, and whenever we are traversing, we have to just count for any DFS traversal. If we are standing here, for example, for this problem only, let us take here. Suppose this is the sample input. So let us take this input as example. So the logic is very simple. We have to simply do a DFS traversal. Simply do a DFS traversal with the given I and j on the cell which we are standing. Once the DFS is being traversed, what we will do is simply add a count plus 1 equal to the DFS traversal. Suppose if we are doing a DFS traversal from here, so our count will be increased by 1 if all the DFS is being traversed from this unit. So currently we are not going to do any DFS traversal if we are standing here because all the other direction are having water. So here the count will be how much? 1 for this one if we are standing here. Now if we are standing here, we are going to start from here. So count plus equal to DFS of I comma j, right? So here it will start, count will be 1 for this cell, the count will be 1. Now it will go here in this direction. For example, we have a direction list in which we will move in all the 8 direction. Now it is going in the right direction, so we will land here on this cell, or either we can land here. It depends in which order we have kept the direction list. So usually we used to keep up, down, then left, then right, then top left, top right, bottom left, then bottom right. In this direction we will be keeping the value in the direction list. So I think we are not going up, we are going in the right direction. So if we are here on this cell now, we started here, we are done. Count is 1 here. Now we moved in the right direction. Now you are here. Now so for this cell again we have to move in all the 8 direction. Recursively we have to do the DFS, right? So again a count will be increased by 1 for this unit. So this will be adding 1 in our counter, right? Again we will be going to the next cell, again do a DFS, count 1, next count 1, next count 1. Now we are done. Once we started from here and recursively we traverse all its connected neighbor in all the 8 directions. So once this is done, once the DFS is done, the final count will be returned here 5. So from the cell on which we are standing, and if we are doing a DFS traversal, so go for the DFS traversal and count 1. Again it will go either in any of the 8 direction. If it is going, for example, in the right direction, it will go for the DFS traversal, count 1 for that cell. Similarly, all its connected neighbors will be traversed using a DFS traversal, and for every cell the count will be 1 added in the counter. And at the end, what we will do, we'll simply apply the logic to check if we have started from here, and we got the count as 1. At the end, we will check the maximum, like we will write the logic to get the maximum. Once this DFS is being returned one time, we will update the maximum. Now we move with the next DFS traversal. For this one, it returned the value 5. So in our logic, the maximum value will be updated. Let us take this example, this one. Very simple one. Let's just take this example. For example, this is the grid. Okay. Now there are two things. One is the count plus equal to DFS of I comma j, right? We started from here. For example, we will be starting from the top, right? But just think of a scenario. We started here for this one, and we have one logic to check the maximum. Currently, the maximum is 0. Now, we did a DFS traversal for this one. DFS traversal, no any other DFS traversal for its neighbor. So, count will be how much? 1. So, 1 will be returned. We will update the maximum. There will be logic to check the maximum. Maximum will be updated with 1. Now, suppose we are here. Again, DFS count will be again for this unit. It will be written the 1. Max will be again 1. Now, for these two things we are done. We are here. For this unit, DFS traversal, it will go for one more DFS traversal. So at that time, again one more DFS traversal, and here we have a count plus 1. So for this one, it will return 1, and this 1 will be returned here 1, right? So count will be 1 for this DFS and 1 for this DFS. So total will be 2. So 2 will be returned, and here the maximum will be updated. All the things are being done recursively. So these two are over. For these two again, one will be for this one and one will be this one. So again, value 2 will be returned, but my maximum will be only 2. Let us take some different example, this one. And let us take this one. Suppose we have this cell as an input. So what will happen here? I think we taken the okay. Now suppose this is the cell. Here we have max equal to 0. Max equal to 0. Now suppose we started from this one, DFS of I comma j. Okay, and here we have count plus equal to DFS of I comma j. We started from here. So for this one, no any never traversal. So this will return 1. 1 will return here in the maximum check. So maximum will be updated with 1. We are done for this value. Go for this one. Again same, no any never. Count will be 1. 1 will return. Maximum check will be there. And maximum will be updated with the same value. No change. Now we are here. So for example, suppose we started from here. Let's see how the DFS is being called. If you are standing here, for that cell, count plus equal to DFS of I comma j. For from here again, one more DFS call will be there for this cell. One more DFS for this cell, right? One more DFS for this diagonal value. One more DFS for this diagonal value, right? Now we are done. For this one, we are done. We will be writing the logic to mark if any cell is already visited. So how many total value will be from here? It will return 1 because the logic will be like count plus 1 equal to DFS. It will return 1, return 1, it will return 1, it will return 1, right? And this will return 1. So total how much? 1, 2, 3, 4, 5. Total 1, 2, 3, 4, 5. So this total value will be returned here to check the maximum between 1 comma 5 now. So 5 will be the maximum. We have already solved so many problems where we are calling the recursive function where we used to have the counter logic like this one. Once the value is being written, we'll apply the logic to check the maximum. Let us directly solve this problem. Now, let me zoom this one. They are passing the grid. They are passing the grid. We have to write our logic here. If they are passing the grid, our very first thing is to check if not grid, if not grid, then what you have to do? Simply return 0. If the grid is of size 0, simply return 0. Otherwise, what we have to do? Get the rows equal to length of grid, the same logic what we have discussed in last two sessions. Calls equal to length of grid of 0, right? And here we have to find the maximum, right? Earlier we were simply counting the total island. Here we have to find the maximum. So max size equal to 0. So we are done with the initialization part. Now what's next? Now what we have to do here? We have to take one direction list. Direction equal to, we have to take a list, right? So let me explain you this direction list line by line. We will take for going upward direction. So for going upward direction, the value added should be -1, 0, right? For going up, for going up. This I have already explained you. So these are the value which I am going to take here. This one, this total value, this total value. Okay. So let me write this direction list. 1, 0 for going down, right? For going left, I is constant and j is being decreased by -1. This is for going left, right? Next is for going right. So for going right, 0, 1 for going right. So this is for moving in 4 direction. Now what we will do? We'll write 4 more for moving diagonally. So for going top left, we have -1, -1. Top left, top left. Now top right. For going top right, -1, 1. Top right. If we are going top right, then I value will be decreased and j value will be increased. I'm not writing anything fancy. This thing I have already explained. Now going bottom left. So for going bottom left, I will be increased, j will be decreased. Bottom left. And the last one is bottom right, where both the value will be increased by 1 unit. This is bottom right. So this is my direction list. So this is the same value which I have explained you here already. Same logic. I have not written anything new here. Now we are done with the direction list. Now what's next? Now what we will do? We will go for I. So for I in range of rows, let us go row and column wise, and for j in range of calls, right? If grid of I and j, if grid of I and j equal to 1, means if it is land on the grid which we are standing, if it is land, then it is of our use, means we have to go for the DFS traversal by passing this value DFS of I comma j, right? Go for DFS of I comma j, and since we are going for DFS of I comma j, it will return a count, right, which we have discussed currently. So let us save that value in island count. Island count equal to DFS of I comma j. Okay, so once we got the island count, what we have to do? Once we got the island count, our next logic is to get the maximum. Max size equal to max of this max size comma island count. So we have taken here max size as 0. So we are updating here. Once this DFS traversal is returning the island count, we are going to update our max size. Once we got the max size, at the end we will return this max size, right? So this is the logic to call the DFS function. Now we have to define the DFS function here. Define DFS in which it will accept row comma column. Now what we will do, the cell on which we are staying, that is land. So we are passing that I comma j value in this DFS. So our very first task will be to mark this grid of row comma column to water, cause on the cell which we are standing, that was land. That's why we went for the DFS traversal. So when we are in this DFS traversal function, what we will do, we'll simply mark that cell as a visited by marking it as a 0. Now we are done. This logic is for mark as visited, right? So once we are done here, what we will do, let us iterate in the direction list. So for dr comma dc in direction, it will give this up, down, left, right, top right, bottom left, and bottom right, one by one. What we will do, we will update the row and column value. So new row and new column will be row plus dr, this will be the new row, and the column will be col plus dc. So we are standing at row and column, we simply updated with dr and dc. The same logic which I explained here, we are standing at, this is our row and this is our column. Row and column plus this is my dr and this is my dc. Now we got the updated new row and new column. Now what we will do, we will check the boundary condition. If this new row, it should be greater than and equal to 0, and it should be less than the row, right? Means the new row should be greater than equal to 0 and less than row, and at the same time this dr should be greater than equal to 0 and it should be less than col, right? Means we are inside the grid. This logic is just to check we are inside the grid. Inside the grid means we are inside the grid. Logic for the boundary condition means we are inside the grid. Once this is checked, next thing is we have to check and at the same time grid of this new row and new column. This is for checking the boundary condition. If we are inside the grid and at the same time on the cell which we are standing, if it is equal to 1, it is equal to 1 means that cell is of our use, means we have to go for the DFS traversal with this new row and new column, right? You have to go for the DFS traversal with this new row and column. So once we are going for this new DFS traversal, what we have to do, let's just take one counter count equal to 1. We will initialize the count by 1 because if we are standing on any cell and that cell is a land, means that is of our use, means one cell is already counted. So that's why we are initializing with count equal to 1. Now when we are going for the DFS traversal for its neighbor in all the 8 direction, before that what we will do, count plus equal to the same logic which I explained you. Go for the DFS traversal for its neighbor from the cell which we are standing, but just simply count the cell with one unit for any DFS traversal you are going from the cell which you are standing. And at the end, when all the DFS traversal is done in all the 8 direction for all the neighbors from the cell which we are standing, we got the total count value and we will return this count. Make sense? So once this count is returned here, this is my island count. So at the end we are going to update this max size. This traversal will occur for all the cell one by one, and here we are marking for any cell that is visited that value with 0. Initially it will be 1. So when we are going for the DFS traversal, we are marking that cell with a 0. So we are done. At the end, let us run and see. Oops, something went wrong. So let us see what mistake we did here. So let's start from here. For I, J, rows, columns, all set. Here also rows, columns, direction, DFS, row, column, new row, direction, NR, NC. Okay, here we have to give rows because here we are checking the boundary condition. It should be greater than 0 and less than ROWS rows. Okay, instead of this one, let us write here I comma J to get rid of confusion. Grid of I comma J, new row I and column J. And here we have to check new row should be greater than 0 and less than rows, not dr. It should be new column should be greater than 0 and less than cols, calls, nrn, and say new row and new column. I think this will work now. So I have simply changed this I comma j value just to overcome the confusion with row and column name, because we have already taken here rows and calls. So I just updated I comma j, grid of I comma j, mark the current cell as visited. Again here I updated the value with new row should be greater than 0, greater than equal to 0 and less than rows. New column should be greater than equal to 0 and less than calls. I think this will work. Let us run. Yes, it worked. So let us submit this code. So congratulations, it worked. So we had just made a typo mistake over here. So this was the problem. I hope you understood this problem in a very simple way. But before this problem, I have asked you to go and solve those two problems which I have already explained you, where we had to count the total number of islands in which we were moving in 4 direction, and later on I explained you a problem where we were moving in 8 direction. So this was a similar problem where we had one extra concept just to find the maximum size of the island. So I hope you understood this problem in a very simple way. So if you learned something new, please do give a thumbs up and subscribe to my channel Coding Card, and stay tuned for the next videos. Thanks for watching.